Welcome, Clean Tech Talk enthusiasts. My name is Scott Cooney. I'm your host today. I am sitting down with Brian Nelson, who's the Renewables market leader for ABB's electrification division, responsible for renewable energy growth across the United States. Brian, welcome to the show. Would you mind giving our listeners a little introduction to yourself and your background?
Thanks, Scott. Yeah, really a pleasure to be here. And looking forward to the chat today. So I've been with ABB for coming on 16 years. I had spent the first part of my career really focused on investor-owned utilities, which was really interesting. I got to learn that part of the business, and then have since transitioned into a renewables leadership role where essentially for our electrification business unit, I'm looking after the United States and trying to listen and learn from the market and from our customers, trying to help ABB develop the technologies and solutions that our customers need to be successful. And then, of course, try to just advocate on behalf of ABB in the space and the segment to hopefully expand renewable energies here locally.
Awesome. Well, welcome. And ABB, of course, for our listeners, ABB needs no introduction. You guys are one of the big clean tech giants in the world with 10,000 employees across the world, huge presence across, globally, big leader in electrification and automation. So anybody who's curious can find out more at abb.com. Today, let's talk utility solar, because this is a super fascinating space, and there's some big changes coming. So I understand we're looking at a big conversion from a current, if you'll mind the pun, a current default mechanism of 1500 volt systems that are pretty much the norm at this point. And now we're looking at upping this to 2000 volt DC systems. So for those who are not familiar with utility solar, can you break this down for us in terms of what this actually means? We had 1000 volt was pretty much the standard not that long ago. Mm-hmm. Now it seems the standard is about 1500 volt, and now the technology is coming quickly. So walk us through what this looks like.
Sure. Well, so typically on a utility scale solar projects, and these are projects that are 5 megawatts or larger. In most cases, we're talking about hundreds of megawatts here. From a utility scale perspective. And those solar farms that are utility scale are going to have a bunch of modules spread out. Those are going to be outputting voltage and current, and they are kind of put into strings, obviously. And then those strings are combined in what the industry calls a combiner box. And what that combiner box is doing is essentially bringing all of those strings together, which will then, on the output of the combiner box, go to the central inverter, where we'll go from DC to AC. After the inverter, we will probably go to a transformer that'll take the voltage from a low voltage to maybe a medium voltage. That medium voltage will then find its way to the substation that will be nearby. That will then start the distribution of that power in all sorts of different ways. Substations can be configured, to really achieve whatever the utility needs. But inside that substation, you're probably going to see another voltage jump. So from medium voltage to high voltage, especially as we've seen with utility scale projects, and especially the super, super big ones, they're usually nowhere near a load center. So we got to get it to high voltage so that we can transmit that power to where it's needed. And so, as you said, Scott, we've seen the transition over the last couple of years from 1000 volts to 1500 volts. Essentially what this means is it's on the module level. The module has to be capable to that voltage rating. And over the last couple of years, we've seen that become more and more popular up to 1500 volts. And now we're getting to the point where there are some module OEMs out there who are starting to get to that 2000 volt level. But that's not the only piece of the puzzle. You need a couple of other things, right? You need a combiner box that's capable of 2000 volts, and that's where ABB has a part to play here. And then, of course, you have the inverter as well that needs to be capable of 2000 volts. So we are right there at the starting line of the transition because there are enough OEMs out there to make it possible. And so it's a good time to be talking about it.
Awesome. I'm glad to hear that. So ABB does not make the 2000 volt systems itself, but you guys help with all the electrification in between, all the parts and gadgets. That kind of,
Correct.
yeah.
It's an interesting place to be in because ABB has a pretty robust component business, which means you got to open up somebody else's cabinet to see the good ABB stuff on the inside. And that's where we're really helping here with this 2000 volts, is to make sure that specifically on the combiner box that there's a switch on the inside rated to 2000 volts that can handle that increased voltage. And then on the inverter side as well to make sure that it's capable with a main circuit breaker or contactor or something like that that's rated to that 2000 volts as well. Because those are the three pieces. You need to have the modules, the combiner box, and the inverter all capable at that voltage level, and then away you go.
Awesome. Sounds exciting. So, maybe let's talk a little bit about some of the benefits of this shift. As I understand it's lower cost and potentially higher output. The wiring, all the componentry and parts. Maybe help clarify what this means in layman's terms for uh, you know, a, let's say a system to switch from 15 to 2000 at this stage. What does that really mean?
Yeah, so there's a ton of benefits. Really, three top level benefits, and I'll get into some specifics here. But number one is a lower capex. So these projects are going to be less expensive, which in the grand scheme of things, which has been super interesting to see how the LCOE, the low levelized cost of energy or electricity, is just continued to come down and down and down for solar. And a jump like this in voltage helps that evolution. And so, number one, you're going to have lower capex. You're going to have a slightly higher energy yield. And then, kind of because of those two things, you're going to have a lower O&M. So, if I go back to the capex piece, you're going to be able to get more modules per string, which means fewer strings per megawatt. And that's probably in the rough estimate of about 10 more modules. Because what's happening behind the scenes here, it's a pretty simple equation to understand, but power equals current times voltage. So if we keep power the same and we increase voltage, current goes down. And when current goes down, you can reduce the size of your copper wiring, which can save you a lot of money, which can be a really big deal. So overall, we believe that the jump to 2000 volts DC is going to yield 10 to 15% lower balance of system costs per megawatt. And so that's, not the modules, but the actual electrical balance of system, which can be significant as time goes on. The other piece that's really interesting is that higher energy yield. And because the DC side resistance losses goes down, because of the current going down, you're able to get more energy to the inverter, which is then going to increase the internal rate of return of that system by about a percentage, maybe 0.5 to 1.5%. So not only are you saving money because you can kind of add more modules to the string, which means fewer strings, which means fewer combiner boxes, you have less stuff to buy, you're also increasing the efficiency of the entire system. And because of that, because of less amount of wiring, less amount of conduit runs, reduce labor. So you're going to be able to save money there. And then because you're able to reduce that equipment, the O&M for the life cycle of that project will be reduced as well. So really exciting time to be in the industry and to be thinking about this next step in DC collection voltage.
Terrific. Yeah. And obviously, the less stuff you have, the less cost and the less maintenance and the less stuff that can break down and stuff like that. So all
Yep.
sounds very positive. Is
Yeah.
there anything? So what is like the prediction for the industry? Like how fast is this transition going to happen? It sounds mostly positive. I'm sure there's some kinks to work out and that sort of thing. But what are we looking at in terms of the industry?
I'm pretty bullish that it's going to come on pretty quickly. Last year, I was saying by the end of 2026, but I think as I've had more conversations, it'll probably take a little bit longer than that. So maybe into 2027, maybe this will really start to become super popular. Uh, Really, the limiting factor in all this is equipment. Right now, I believe there's only two inverter OEMs that are capable of 2000 volts. I believe the same or similar on the module side. So there's not a whole lot of supply chain out there to support 2000 volts, but this is coming. One of the limiting factors that we see is just codes and standards, right? Nobody's really super gung ho about installing something that isn't UL listed or doesn't comply with the National Electric Code. And so one of the things that we were waiting on as ABB was UL to update their standard UL 98B from 1500 volts to 2000 volts, so that we could test it, right? So that we can put the UL stamp on it to make people feel comfortable about that solution. So we're there now. We have the standards in place, and that'll really help, I think, other manufacturers come to the party with their 2000 volt solution.
Great. Okay. So overall, with regard to the whole industry, let's say this transition happens by 2027. From where we are right now, if we convert everything over to 2000 volt, if you look at utility scale solar across just the United States, total cost reduction, total energy increase output, any idea of what these numbers might look like? I mean, I know it's a very complicated question, but
Yeah, I think hard to have a crystal ball as to how it'll be fully deployed. Um, I think I'm comfortable saying that it's going to help continue to reduce the cost of solar, which should speed up implementation and deployment of solar, and the opportunity for growth specifically for solar, I think just continues to get more and more exciting. So really optimistic about the change and hope it's an accelerator for solar so that we can continue to decarbonize. But you'll start to see, and we've already started to see gigawatt type projects for solar. Those will probably become more commonplace, tied to batteries, most likely, of course. Um, by the way, batteries, same thing, right? Their voltage levels are increasing, and so if we can all get to 2,000 volts, we can all play nicely together. Um, and so those large scale projects will probably just continue to get larger and larger. And then we really need transmission, right? Back to my point before, typically these are not near load centers, and so the build out of transmission is, I think, super critical for this step on the collection system voltage, really to just take full advantage of the opportunity. So I'm hopeful that we'll see more transmission being built over the next 4 years.
okay. All right. Well, this transition to direct current is interesting, and as a homeowner, I have solar and have a battery system and that sort of thing. This has always been a quandary of the DC-AC,
Yeah.
and so I don't know if you can speak to this, like the smaller scale kind of level of the emerging DC technology, and what it means for efficiency on the commercial, industrial, residential kind of side. How does it happen? What does it look like? What are some of the trends? What are some of the cool emerging technologies in that space? And I'm curious to hear like what kind of efficiency gains we could hope for on the commercial, industrial, and residential sides as well. Like what can we learn from utility scale solar that we can bring down to the rest of it?
It's really an interesting time because, as you indicated, Scott, the AC versus DC is something that this industry has been talking about for a decade plus now at this point. And so I really believe that we are starting to see more and more DC applications come to bear. Of course, you have data centers. A lot of what they're doing is happening in DC. The electrification of transportation, for the most part, that's happening in DC. Drives that are spinning, motors can operate in DC, LEDs, all this stuff. So our lives are really filling up with more and more DC devices. And I think it's probably no surprise to your listeners that when we do the DC to AC conversion, there's some power loss there, right? And so, and in our systems, we can be doing that multiple times back and forth, just based on the complexity of some of the things that we're seeing. So, DC systems are really have a really good opportunity. Renewables are natively DC, right? We have solar output in DC, batteries store power in DC. We charge all of our devices in DC, and so I do think there's an opportunity there. DC power systems can be more efficient because of the lower amount of conversion steps. They can be simpler, right? Because we don't have this zero crossing that can be troublesome. And then they're just more resource effective, less copper, less electronics. And so some of the things that we see on the potentials of DC are, if you can envision, a large maybe fleet charging depot for a truck fleet that's gone newly electric. Those trucks are being charged with DC. Imagine a solar farm in the backyard, so to speak, with some energy storage. All of that can happen in DC. And so right away, we start to see, well, hold on a second. Why should we, from solar, go to AC to then go back to DC to charge the battery? Why don't we just go DC output of solar into the energy storage, and then also, wait, these cars are being charged on DC. So can we now just keep everything in DC, or as much as possible, and avoid some of those conversions that can create some losses in the system? And I think we're really starting to get there as far as technology is concerned. AC does have one really good benefit. It crosses zero. So you're able to break the current at that time to, I think, save safety and reliability and things like that. But solid state circuit breakers are becoming more of a reality. Solid state transformers. So technology is beginning to support some of those things. So really interesting opportunity that we are learning on the backs, I think, of utility scale solar, where we're starting to see this voltage increase. So then as ABB, a component supplier, we have to make sure that we're designing to this. And oh, by the way, I don't expect us to stop at 2,000 volts DC collection systems, right? There's going to be some pretty interesting stuff out there. I'm sure somebody's going to say, well, why don't we do 2,500 volts or whatever?
Of course.
Right. And so now, again, we're really working on the components required to make a DC system a reality. And so I'm really excited about the future state of that.
Yeah, you're right. Somebody will get 2,500 before you know it, and we'll be talking about that in a year on another podcast. So
Yeah, that's right.
yeah. All right, Brian, thanks so much for your time today. Really appreciate that. Any closing remarks with regard to I don't know, your wildest dream for the renewable energy market in the United States?
Great question. I believe in decarbonization through electrification, and renewable energy is a really exciting and technology focused industry. So what I would say is my hope for renewables, and I believe ABB does have a part into this, is let's continue to make it the cheapest form of energy production, and then let's try to get it out to as many people as possible. And I would also say, too, that efficiency is important here. It's, just as important to save electricity as it is to generate clean electricity. And there's a lot of opportunities there, too. So I think those two things together, I see a decarbonated future for us in the United States. It's going to take a long time. It's definitely going to be a transition. But I think the technology is moving pretty fast, which will hopefully continue to enable that future.
It's inevitable, only a matter of time. We just don't know what that time looks like.
Right.
Yep. All right. Thanks so much, Brian. Appreciate your time today.
Thank you.
All right.